So when solving rational functions, there are two methods. Let's look at the first method. Whichever method you pick, you need to find the LCD. So what is my common denominator that's divisible by 2, 3, and 6? 6, right? 2 goes into 6, 3 goes into 6, 6 goes into 6. Method 1 says take all of this and multiply by 6.
Yeah.
So when I take the first fraction, so 6 times x gives me 6x over 2, plus now multiply 6 by 2x gives me 12x over 3, and last but not least multiply 6 by 1 gives me 6 over 6. Now that we've done that, we need to simplify. So 6x divided by 2 is 3x. 12x divided by 3 is a 3 goes into 12, 4x. And then 6 over 6 is a 1. So notice what happens when you multiply by the LCD. It turns your fractions into a single. There's no more fractions, right? So this is what I mean by no fractions. Notice we don't have any here after simplifying. Now you just need to solve for x. So what is 3x plus 4x? 7x equals 1. And then last but not least, divide by 7, x equals 1 over 7. So there's the first method, multiplying everything by the LCD. So for method 2, it's asking to set the denominator to the LCD, like we should know how to do with fractions. So each of these needs to be over 6, over 6, over 6. Oops. Plus equals. Now, how do we get there? I have a 2. 2 times what equals 6? 2 times
3.
Times 3. So I need to also multiply the top by 3 as well. So I get x times 3, that's a
3x.
3x. The next fraction, how do I get from 3 to 6? I multiply by 2. So I'll multiply the top by 2. 2x times 2 is a 4x. And then 6 times 1 is 6. So I'll multiply the top and the bottom by 1, and that gives me 1 over 6. Now what the second method is saying, now that you have the denominators that are equal, we could forget about the denominators. We're already good to go. They're equal. Now we need to worry about the numerators. So let me just take out the numerator, which is 3x plus 4x equals 1. And we have already seen this equation. So add combine like terms. 7x equals 1. X equals 1 over 7. So there's the second method. First method is to multiply by the LCD, the whole thing. Second method is to set the denominator to the LCD and then just look at the numerator once you're done. So slide 9. That was a very simple equation. Now let's solve more complex rational equations, the ones you'll be seeing here in college algebra. Like so. 1 over x minus 2 plus 1 over x plus 2 equals 4 over x squared minus 4. Regardless of the method you prefer, you need to find the common denominator. Hint, when expressions in the denominator are factorable, it is very helpful to factor the denominators to find the correct common denominator. So what is my common denominator with this?
2 x squared minus 4.
X squared minus 4. But let's factor it. Let's keep all our LCDs in factored form. So what is the factored form of x squared minus 4? I'll give you a hint. Hints are inside the problem.
X minus 2 and x plus 2.
Very good. X squared minus 4 is the LCD, and it factors into x minus 2 and x plus 2. So there's my LCD. Now slide 10, restricted values. Rational expressions contain fractions, and we understand that the denominators cannot be 0 because we cannot divide by 0. We must exclude those values that make the denominators equal to 0 for our solutions because they won't satisfy the original equation. These are called restricted values. For example, for the equation 1 over x minus 3 equals 5 over x, we must throw away x equals 0 because I cannot have a 0 in this denominator, and x equals 3. I cannot have a 3 here because 3 minus 3 is 0. That's a no. It'll make both of those values in the denominator 0. So what values must we exclude from this problem? What would make the denominator 0? So look at each of these fractions one at a time and decide what makes it 0. So let's go here. Let me look at my restricted values.
Ah!
So 1 over x minus 2, what would make my denominator 0? What value for x?
Plus
Plus what?
2.
Very good, plus 2. 1 over x plus 2, what would make my denominator 0? A minus 2. And for this one, that actually factors into x plus 2 times x minus 2, what value for x can I not have?
0.
No.
Oh wait,
Look at each of these terms separate. We did this when we saw quadratics, the zero product property. What would make this one 0? X plus 2?
X minus 2.
A minus 2. X minus 2? Plus 2. So this actually contains the 2 that we already found here. Plus 2 and minus 2. Restricted values. So if I get any of these as my answer, I have to throw them away.
So it's the same thing. Basically.
Now let's practice method number 2 with the same equation. Let's write this equation with the same denominator. So we're setting the denominator equal to the LCD, which was
Plus 2 minus 2.
x minus 2 times x plus 2. Now, how do we get from there to our LCD? This first one, x over x minus 2. Which part is it missing? It's missing my x plus 2. So I need to multiply this one by x plus 2 on the top and the bottom, which makes my numerator x plus 2. This one has the x plus 2, but it's missing the x minus 2. So multiply that on the top and the bottom makes my numerator x minus 2. And then what's my numerator here?
4.
Very good. It already has both x plus 2 and x minus 2. So you're not changing anything. So it stays as a 4. Now the second method, remember, says take your numerator and put it together because we're no longer worried about the denominator. So that gives me x plus 2 plus x minus 2 equals 4. And now let's solve for x. Oops. That should be a 2.
Damn, this should feel weird. X, so the equation that we're writing is x plus 2 plus x minus 2 equals 4.
Yes, that's what you're going to write.
Damn.
And now let's solve it. So x plus x is 2x. 2 minus 2 is 0. And that equals 4. So I get 2x equals 4, which means x equals what?
2.
2. X equals
I don't know why that was so
2.
simple, but it took a fat minute.
Now take note of extraneous solutions. If after you solve your equation algebraically and find the value that was previously excluded, so your restricted values, is not valid in your original equation, we call those solution extraneous solutions. Extraneous solutions must not be included in your final answer as they did not make the original equation true. Did you find in your algebraic solution any restricted values that must be excluded? So I found that x equals 2. Can I accept that as an answer? Makes the denominator 0. We had already found out that 2 was a what?
It was
Restricted value.
Yes.
So this cannot happen. This is called an extraneous solution.
So we found them at the beginning. Okay.
So the answer I got, I have to throw it away. Therefore, my solution is...
No solution.
Very good. No solution. No solution. I could not find any value for x that'll come out and make this true.
There is no.
All right, let's look at this problem. Can somebody tell me what is the least common denominator that I'm going to use here?
X minus 6 and x minus 2.
Very good. X minus 6 and x minus 2. Next, we need to think about restricted values. So for what values for x will cause my denominators to be 0?
6 and 2.
Okay, for this fraction, 6, and for the other one, 2. Likewise, this one, once it's factored into x minus 6 times x minus 2, I see that it also cannot have a 6 and a 2 in the denominator. Let me clean that up. All right. Next, I want to use method 2 because that's going to be best here. I really don't advise you having to multiply this whole thing by a quadratic. So we'll just go ahead and use method 2. So x minus 6, x minus 2. Now, let's see what it takes for us to get there. As I look here, I have my x minus 6, but I'm missing my x minus 2 I need to multiply. To the top and the bottom. So that sets my numerator to x minus 2. The next one has x minus 2, but it's missing the x minus 6. That I'll need to multiply, so that makes that numerator x minus 6. And then what's my numerator for this one? Yep, I already have the LCD, so nothing changes, so that stays a 4. Now what we want to do is look at only the numerator. So that has x minus 2 plus x minus 6 equals 4. And solve for x. So add my x's together gives me 2x minus 8 equals 4. Add 8 to both sides. Gives me, 2x equals 12. Divide by 2, x equals 6. Now, is there anything wrong with my x equal 6? Yes, very good. I notice that 6 cannot be one of my answers. If I plug it in, it makes a 0 in the denominator. So this is a no. This is, like you said, an extraneous solution. And since that was my only answer choice, what is my final solution? No solution. I end up with another no solution.
I don't know how we're gonna be